Good evening, everyone. I welcome you all on the behalf of StudyIQ IAS English. My name is Pritesh Maturkar. I welcome you all to this exemplary journey. I welcome you all to this very dramatic endeavor where I take you all on a world tour, where I take you all rather on a personalized guided world tour. And in this world tour, we will be learning the basics of a discipline called as geography. And in this world tour, I will be using the most potent tool in geography, that is maps. Hence, the session is entitled Geography Through Maps per se. Okay, so I welcome you all to the seventh session of this series. This series being a continuing series, so we will be picking off from where we left yesterday. And in this series, I intend to achieve two things. Number first, using these lectures, you all and including me will be covering roughly 50 to 60% of your GS foundation syllabus. So my coverage will be predominantly based on the understanding of NCERTs and the understanding of a book called as Certificate Physical and Human Geography by Goncheng Leon. And mind you guys, the NCERTs will be primarily the 11th NCERTs, both the world physical environment and India physical setting. So we'll be biasing our four in this series on these three references. And second, using this knowledge, you can of course improve upon your content. You can also build up your advanced level concepts. And in this series, I also tend to include current affairs for each and every one of you. Okay, so in short, we will do the entire world geography. We will try to cover all the world's physical aspects. We will try to also involve some political issues, some social issues, some economic issues, some historical issues. So in general, treat this discourse as a complete preparation for your GS. Okay, and if you do this kind of curriculum dedicatedly, okay, if you do the homework which I give you in every session, and if you follow me closely, I am guaranteeing you guys this session will translate roughly into 15 to 20 marks in your prelims and approximately 100 to 200 marks in your mains. And if essay comes in your purview, it can go well above 300 too. Okay, so that is the utilitarian value of this foray. So welcome all. So from today onwards, I'm starting a new innovative approach for beginning up the sessions. So in the first few seconds, the background which you are seeing, so this is one of the location which I covered yesterday. So the beautiful picture that you are seeing over here on your screens is a location called as Namib Desert. We all did the Saharan Desert. We all did the subtropical deserts of the Tropic of Capricorn. And when we were traversing in Africa, I introduced you to a desert called as Namib Desert. So see how beautiful this photo is, where the Namib Desert is meeting the South Atlantic Ocean. Okay, so Earth is so beautiful. Okay, I wish that each and every one of you sees how beautiful the earth is through this session, and one day you all travel with me to such beautiful locations and we will go there someday. Okay, there is hope, there is always success. So you and me, we both need to prepare very diligently, prepare in the sense that I have to prepare you for your journey, and in the end when you become successful, you have to take me to these locations too. Okay, so very beautiful portrayal of the Namib Desert meeting the Atlantic seaboard. And guys, this is the beauty of geography. You can practically see whatever you are being taught. You can practically feel whatever you are being taught. Okay, so every lecture now I will be beginning with a beautiful picture of a location which we did yesterday. And guys, you should also use this as a trick. What is this trick? That if you are getting confused with the entries in the atlas, you should just Google up the images. And what you do is you prepare an index of all those entries along with their pictures. Once that registers audio visually in your brain, you will never forget those entries. Okay, so last time, this is the Namib Desert meeting the Atlantic seaboard. So before any further ado, let me just quickly introduce myself so that you can contact me, you be in touch with me. My name is Pritesh Maturkar. Okay, I will be your primarily faculty for handling the geography GS discourse, this being a basic or introductory discourse. So treat this as a preparatory discourse for your main preparation. And you can reach out to me on a Telegram channel called as Geography by Pritesh Maturkar. So it's an open channel where I keep on posting the tidbits with regards to the geography discipline, where I keep on posting some of the links every day and also some of the important PDFs which are important for your mains perspective as well as from prelims perspective. And mind you guys, those PDFs are handcrafted by me, so you can directly utilize those PDFs in your answer writing too. Okay, you can just do a global search on Telegram. It is called as Geography by Pritesh. So at Geography by Pritesh, just do a global search and you will be comfortable with the current affairs of the geography too, from the prelims centric perspective, from the main centric perspective. And if some of the issues are personality altering, if some issues are character altering, okay, so we will do that issues too in this channel and in these lectures too. Okay, so let's begin with our today's discussion. So in every lecture, in the first 5 to 10 minutes, I tend to summarize whatever we did yesterday. So the same thing I will do today. So in 5 to 10 minutes, I will be summarizing everything and then we'll be moving ahead. So in yesterday's session, I introduced you to the atmospheric circulation cells. I introduced you to the pressure belts of Earth, and I introduced you to the surface winds on Earth, or the global planetary winds. I didn't say this name explicitly because I reserved that name for today's discussion. So the winds which I taught you yesterday, the trade winds, the westerlies and the polar easterlies, they are basically a group of winds called as the global planetary winds, because anywhere you go on Earth, you will always find those winds. Okay, so please make sure that you are comfortable with the naming global planetary winds. So I'm quickly recapping you for you all the winds which we did yesterday, okay, and how you have the cells. So let us take the full use of this digital board. Let us draw the Earth in its original spherical shape. Okay, the shape of Earth is spherical, rather it's geoidal. It is bulging in the center and it is flattening at the poles. So this is the shape of Earth. Okay, okay, so if I'm drawing the equator for you all, so let's assume this is our equatorial low pressure belt, ELPB. Okay, this is our equatorial low pressure belt. You have two subtropical high pressure belts, okay, one per hemisphere. So you do have two subtropical high pressure belts, one per hemisphere, and these pressure belts at around 30 to 35 degrees north and south. Then you have the subpolar low pressure belt. Okay, this is our SPLB. You again have subpolar low pressure belt. This is called as SPLB. And lastly, you have what? You have the polar high pressure belt. Okay, so if I'm writing for you all the pressure belts, so this being the 0-degree equator, so you have these equatorial okay, you have the equatorial low pressure belt. Then you have subtropical high pressure belt at around 30 to 35 degrees north. This is called as subtropical high pressure belt. Again, you have 30 to 35 degrees south. You have the subtropical high pressure belt at around 60 to 65 degrees. 60 to 65 degrees north. You have the subpolar low pressure belt at around 60 to 65 degrees south. Again, you have the subpolar low pressure belt, okay, and at the poles 90-degree north, okay, you have the polar high pressure belt. You have again polar high pressure belt at 90-degree south. This is called as polar high pressure. Okay, now let us quickly recap why these pressure belts are being induced. Okay, so why the equatorial low pressure belt is being induced? Why? Because of what? Because of direct insolation of the sun. Mind you, the equatorial low pressure belt is thermally direct belt. Why? Because the air will rise up from the equator, okay, and as soon as it rises, Because of intense vertical convection, you are having the equatorial low pressure belt being formed. As soon as the air rises, it diverges towards the poles, and as it diverges towards the poles, instead of sinking at the poles, it sinks at the horse latitudes of around 30 to 35 degrees north and south. And why this is so? Because of a force called as Coriolis force. Coriolis force is what kind of force, guys? Coriolis force is that force which acts on a horizontally moving body because of the rotation of earth on its axis from west to east. So the earth is rotating on its axis from west to east, hence you have the Coriolis force acting on the body, and this Coriolis force tends to do what? This Coriolis force tends to cause apparent deflection. This deflection is towards the right in the northern hemisphere and towards the left in the southern hemisphere. So because of Coriolis force, the air descends, and it descends at around subtropical high pressure belt around 30 to 35 degrees. So one branch of it comes towards the equator, completing this particular cell. This cell is called as Hadley's cell. This cell is called as Hadley's cell. Okay, so one branch comes over here, another branch moves towards the subpolar latitudes where it meets with the cold air coming from the poles. And what is happening at around 60 to 65 degree? The air is forced to uplift. The air is forced to uplift. Okay, how this is happening, guys? Yeah, good evening, Krishna. So the air is coming from the subtropical high pressure belt like this. You have cold air descending from the poles, and as these two airs are meeting, they are rising upwards. So treat my shirt, okay, let's assume my shirt to be the surface of earth. So one wind is coming like this, another wind is coming from the polar latitudes. So let's assume my hair as the poles, let's assume my chest as the subtropical high pressure belt. So the air is meeting, and let's assume my neck to be the subpolar low pressure belt at around 60 to 65 degrees. So you have this air coming from above, coming from below, and the air is forced to rise like this. Okay, so because of this, you have another two cells meeting and completing over here. So this is cell number 2, and this air will move towards the poles and it will sink over here. So this is cell number 3. So this cell number 2, this is called as Ferrel's cell. This is called as Ferrel's cell. And cell number 3, this is called as what? This is called as polar cell. Okay, this is called as polar cell. So these are the pressure belts of the earth, and these are the atmospheric circulation cells: Hadley's cell, Ferrel's cell, and polar cell. And mind you guys, out of these three rather, only Hadley's cell is induced thermally. Okay, only Hadley's cell is thermally induced. Okay, mind you, rest of the two cells, they are induced how? They are induced dynamically. So if I'm considering polar cell and the Ferrel's cell, these cells are induced dynamically. Why? Because of the rotation of Earth on its axis from west to east. So dynamism of the Earth's motion is coming into play. Okay, so please keep this in mind. Earth is not a static system. Earth is a dynamic system, just like our brain. Okay, you have so many thoughts coming in your brain every day. It's like biryani in your brain. So similarly, everything is helter-skelter over on Earth because of its dynamism. Okay, so please make sure that you are comfortable with this aspect, that polar cell and Ferrel's cell are dynamically induced, whereas the Hadley's cell is thermally induced. Okay, so let's move ahead. Now let's see the wind movements. Okay, so ideally the wind will move from high pressure area to low pressure area. Why? Because high pressure zone will be the zone of divergence. If let's assume that I am compacting the air between my hands. Okay, the air is getting compacted in between. So if the air is getting compacted, it needs to escape because the pressure is building up. Hence, the high pressure zone will be the area of divergence. Whereas low pressure zone, so if I'm holding a low pressure zone in my hands, so the air is thinner, the atmospheric is thinner. Okay, the air is not concentrated, the air mass is very low. So what will happen? Air will diverge from the high pressure areas towards low pressure areas. So low pressure areas will be the areas of convergence. Please make sure that you are comfortable with this. In mains, you need to do properly with the terminologies. You need to understand the terminologies very, very properly, guys. So if you have a discussion on high pressure regions, you should be crystal clear that high pressure regions are the areas of divergence. And if you have a discussion of low pressure areas, so you should be crystal clear that low pressure areas are the areas of convergence. So if you see in this diagram, you have the subtropical high pressure belt, so the air will diverge from this towards the equatorial low pressure and the subpolar low pressure. The polar high pressure being the area of high pressure, air will diverge towards the subpolar low pressure, and similar thing will happen over here. But will the air move in straight line? No. As I told you, which force will come into play, guys? The Coriolis force. Coriolis force will do what? Coriolis force will cause aberrant deflection in the moving body. It will cause aberrant deflection in the wind direction towards the right in the northern hemisphere and towards the left in the southern hemisphere. Now, but naturally you will have a question, sir, why right in the north and why left in the south? Why not opposite? Okay, so the answer is basically linked to the tip of the earth and the center of gravity of the earth. So let's not move into the technical discussions now. For now, just remember that whenever you will brush in the morning, if you are to the north of equator, water will always swirl towards its right and go down in the sink. And if you are brushing and if you are to the south of equator, water will go left in the sink and it will then swirl down towards the sink. Okay, for now, just remember this. Okay, so ideally, the wind should come from high pressure to low pressure in straight lines, but that will not happen. If I'm showcasing you the direction of winds, which is actually over there. So, coming from high pressure to low pressure, the winds will diverge how? They will diverge towards their right in the northern hemisphere and towards their left in the southern hemisphere. So, wind is coming from high pressure to low pressure, it will diverge like this. Okay, it will diverge like this towards its right. If the wind is coming from high pressure to low pressure in the southern hemisphere, it will start diverging towards its left like this. It will start diverging towards its left like this. Okay, if the wind is coming from high pressure to low pressure in the northern hemisphere, it will diverge towards its right. So the wind will come like this, the wind will come like this. If the wind is coming from high pressure to low pressure in the southern hemisphere, the wind will diverge towards its left. Okay, so the wind will come like this, the wind will come like this, and the wind will come like this. Okay, so we call these winds as what? We call these winds as what? Coming from northeast and southeast, we call these winds as the trade winds. So I'm rubbing the pressure cells for you all. I hope this concept is clear to you now, everyone. So I'm rubbing the pressure cells once and all for everyone. Okay. This is our polar high pressure. Okay, so the winds that we see over here, this and this, these are called as what? These are called as the northeast and the southeast trades. Northeast and southeast trades or trade winds. Why these are called trade winds, guys? Because they have known to help trade. Okay, in the ancient times, you didn't have diesel powered boats, you didn't have diesel powered big ships. So because of this, you had the option of only wind sailing. Hence, these winds have known to help the trade, and hence we call them as trade winds. Okay, yeah, good evening Nandana, you are new to this channel, so welcome aboard. Okay, I am also starting fresh, so you will be pretty comfortable with me. Okay, do watch the previous lectures for our understanding, but even if you join today, I bet you will get everything. Okay, so let's move ahead. So these are called as northeast and southeast trade winds. Why trade winds? Because they have known to help the trade in the past. Okay, so as now if you move from subtropical high pressure to subpolar low pressure, the winds, they tend to come from west. Okay, dare I say, okay, they tend to appear even from more west. Why? Because as we move from the equator towards the poles, the Coriolis force deflection will increase. Why this is so? Today we'll finally get the answer of it. Okay, why Coriolis force deflection will increase if we move away from the equator towards the poles? So as this wind tends to appear from the west side, these winds are called as westerlies. These winds are called as westerlies. Okay, these winds are again called as what? Westerlies. Okay, mind you, this is very, very important. Okay, I bet every one of you has studied this in standard 10th, but you never got the real reason why do we have wind movements like this. Okay, so it's like history will repeat itself, first as tragedy, then as fast. So those of you who are joining me today, you must have thought that, oh, geography is done, we are done with it in the 10th standard itself, but everything will come back and haunt you. Mind you, the earth is round, it's not flat, so what goes around will always come around. So never run from your challenges, never run from the hurdles, because they tend to come back in life. Okay, so similar is with earth, to everything that will go around will surely come around. Okay, so these are westerlies. Okay, now guys, I'm moving my discussion ahead a little bit, so I am introducing you to the intricacies of Coriolis force deflection, because we need to understand the direction of flow of the polar easterlies. Okay, and what do you mean by polar vortex? Okay, so let's move ahead with the discussion of polar vortex and what do you mean by actually the Coriolis force. Okay, so if I'm writing the Coriolis force for you all, so Coriolis force is what? Coriolis force is a apparent force. Okay, it's a apparent force. Okay, it's a apparent force. Okay, it comes into play because of what? Because of Earth's rotation. Because of Earth's rotation. Okay, the Earth is rotating on its axis, hence you have the Coriolis force coming into play. The Earth is rotating on its axis from west to east, hence you have this apparent deflection. What it will cause? It will cause deflection in the moving bodies, but it is only valid for which kind of movement? Only for horizontal movement. It is valid only for which kind of movement? It is only valid for horizontal motion. And this deflection is what? This deflection is towards right in the northern hemisphere. Okay, and it is towards left in the southern hemisphere. Okay, now what do you have exact correlation with the latitude and the Coriolis force? So please remember this point as very, very important, hence I am writing it in dark red. Okay, guys, those of you are watching my lectures, you are free to comment whether you want the board to be black or you want the board to be more white or you want to be the board of any different color. Okay, it's an interactive session, guys, so you are free to comment on whatever improvement you need. I will be changing according to you. But mind you, geography as a discipline is a very interconnected discipline. You need to understand the concepts very well. So please treat this session as a two-way session. Okay, it's not that whatever I'm telling you have to follow exactly. You can also suggest some feedbacks. You can also improve upon. So if I'm writing something on the board and if you're not feeling comfortable, you are free to comment, those who are watching. Okay, so now I'm writing something in red. Red means it's extremely important. Okay, so what Coriolis force has got to do with the latitude? Now please remember, Coriolis force has what? Has a sine angle component. Has a sine angle component. As a sine angle component. As a sine angle component of the latitude. Okay, so because of this, if you consider the Coriolis force on the equator, Coriolis force will be 0. Why? Because sine 0 degree will be 0. And if you consider the Coriolis force on the polar locations, so sine 90 will be 1. So what does this mean? As we move from the equatorial areas to the polar areas, okay, Coriolis force deflection will increase. The Coriolis force deflection is bound to increase as we move from equatorial latitudes to the polar latitudes. Why? Because the Coriolis force has got a sine angle component to it. Okay, so if you consider the equatorial areas, the Coriolis force is almost 0, so there will be no deflection. But as we start moving from equatorial areas to the polar areas, the Coriolis force deflection will increase. So imagine this again to be the equatorial areas and yourself as the polar areas. So if a wind is coming like this on the equatorial areas, it will not deflect, but as we move ahead, the deflection will increase and the wind will start deflecting. So this is how you have increased deflection towards the polar regions. Why? Because you have sine angle component. Okay, so I'm again re-summarizing or reiterating for you. Okay, so Coriolis force will do what? Coriolis force will cause even more deflection. Okay, the deflection increases. The deflection increases polewards. The increases polewards. Okay, and again, very important point, Coriolis force deflection has got nothing to do with the velocity in the sense that it has got one relation only with the velocity and no other relation with velocity. Please understand this very properly. Okay, Coriolis force cannot affect the velocity of the moving body. So let's say this pen is coming towards you at a speed of, let's say, 20 kilometers per hour. So this is 20 kilometers per hour speed and the pen is coming towards you. Okay, so Coriolis force cannot impact the magnitude of velocity of this pen. This means what? Coriolis force cannot increase the velocity of this pen. So as soon as the pen is starting to move from equator towards the poles with the speed of 20 kilometers per hour, it will be coming only by 20 kilometers per hour. Why? Because the velocity with which the pen is moving from equator towards the poles, it will be depending on with what pressure or with what force this pen has been thrown. If I'm considering with regards to winds, so how intense the pressure conditions are. So the more the pressure gradient force, the more will be the velocity. So Coriolis force has got nothing to do with the velocity of the moving body. So it does not mean that velocity and Coriolis force are not related. I'm again reiterating. What is the relation between velocity and Coriolis force? It has got nothing to do with the magnitude of velocity. But the more the magnitude of velocity, the more is the Coriolis force deflection. Okay, what do you mean by this? So everyone, after this class, please do an experiment. Those who will be watching these lectures, especially the boys, especially the cricket fans. Now IPL is going on, you have so many camera angles, you have so many languages, so just do an experiment. Okay, take a ball and throw with a little speed. Take a ball, throw it with more speed, and take a ball, throw it with such a speed that your shoulder joint should come out of its socket. Okay, and when you do this, you will see that the ball, it starts to swinging. Why do you have that swing? Because the more the velocity of the moving body, the more is the Coriolis force deflection. So this is the correlation with the magnitude of the velocity of the moving body with the Coriolis force deflection. I'm again reiterating, Coriolis force cannot increase the magnitude of the velocity of the moving body, but the more the velocity of the moving body, the more is the Coriolis force deflection. So if this pen is coming by 20 kilometers per hour towards you from equator towards the poles, the deflection will be less. But if this pen is coming by around 100 kilometers per hour, 200 kilometers per hour, then the deflection will be very high. Okay, so I'm writing this again in capital red so that you get this concept very properly. Okay. So Coriolis force, okay, cannot increase the velocity of the moving body, but this but is very important, and if you get this but very properly, then your concepts of climatology are taken care of, because all of this has got to do with the weather and climate of the temperate areas, the taiga areas and the tundra areas. Okay, but the more the velocity, the more the velocity of the moving body, of the moving body, of the moving body, okay, the more will be, the more will be, the more will be the Coriolis force deflection, the more will be the Coriolis force deflection, the more will be the Coriolis force deflection. Okay, please get this point very properly. Okay, but the more the velocity of the moving body, the more will be the Coriolis force deflection. So if I am throwing this pen with a speed of 20 kilometers with you all from equator towards the poles, the plane will not deflect that much. But if this pen is being thrown by a speed of 100 to 200 kilometers per hour, okay, the plane will start deflecting. Why? Because Coriolis force is related positively with the magnitude of the velocity of the moving body. Okay, so what does this mean actually, guys? Okay, what this actually translates in actuality. So for that, we will again take the reference of the previous diagram that I have drawn. Okay, so the trade winds, the southeast trade winds and the northeast trade winds, they will not deflect so much. Why? Because you are in the equatorial latitudes and we are in the tropical latitudes, so the deflection will be slightly less, but the westerlies will deflect much further than as compared to the easterlies. So westerlies will truly come from the west, they will truly come, they will truly come from west, they will truly come from, they will truly come from west, they will truly come from west. Okay, so you need to understand this very properly. Okay, so if you are residing in the latitudes of 40° north and between 60° north, so you will see, or you will perceive, like, of course you cannot see the wind, but you can perceive the wind. So you will see what, you will perceive what, that wind is truly coming from the west. So if towards my right, you are left, so if this is the west direction, so winds will tend to come more from the west. Why? Because as we move away from the equator towards the poles, the Coriolis force is increasing, and because of this the deflection will increase. And mind you, if the westerlies are coming with even more speed, then they will again tend to come properly from the west. And guys, mind you, this knowledge is very essential for you to understanding the higher level concepts of jet streams, of Rossby waves too. Okay, so don't get frightened by the names. I know that some of you will get frightened, sir, what are these names, we don't know. We will, I'm there, we will go there slow and slowly. Slow but steady will always win the race, and geography is all about conceptual understanding. Once you get the concepts, once you get in line with me, once you start liking me, and I hope that everyone starts loving me too. So once you start loving me, you will also fall in love with this discipline. But mind you guys, don't fall in complete love, don't fall in blind love, otherwise you will end up teaching like me. That's the beauty of this discipline. Okay, so jokes aside, let's move ahead. Now let's move towards the focus area of the polar regions. That is why I introduced you to Coriolis force. Okay, so for this I will be using a separate diagram for the polar latitudes. Why? Because once you go towards the polar latitudes, the Coriolis force deflection is maximum anywhere as compared to the earth. So let us use another diagram for this. So I'm considering only the half hemisphere of the north for this. So now let's consider the areas between the subpolar low pressure belt between 60 to 65 degrees north and the polar region specifically. Okay, for now let us forget the areas which are to the further north. Okay, so treat this as your subtropical high pressure belt. Okay, I'm writing deliberately over here. So treat this as your subtropical high pressure belt. Okay, and treat this as your subpolar low pressure belt. Okay. Okay, treat this as your subpolar low pressure belt. Okay, treat this belt as your subpolar low pressure belt. Okay, so this is our subpolar low pressure belt. This is 30 to 35 degrees north. This is 60 to 65 degrees north. Between the subtropical high pressure belt and subpolar low pressure belt, you have the westerly winds. Okay, you have the westerly winds. So the westerly winds are coming like this. So this is the direction of the westerly winds, like this. Okay. Okay, now let us zoom in on this part. Let us zoom in with the polar high pressure of 90° north and the subpolar low pressure of 60° to 65 degrees south. Now, between this, what will happen? The Coriolis force deflection will be maximum. Okay, so if I'm considering this part of Earth, the Coriolis force, the Coriolis force deflection, the Coriolis force deflection, the Coriolis force deflection, the Coriolis force deflection will be maximum, and hence because of this, as soon as air starts to move from the polar areas towards the subpolar low pressure areas, the air will get immediately deflected towards its right. Mind you, air will immediately be deflected towards its right. Why? Because the Coriolis force is maximum at the poles. Sin 90 is equaling 1. Hence, the Coriolis force deflection will be maximum, and the air, instead of coming at the subpolar low pressure belt, the air will start swirling around the poles. Okay, so if I'm drawing this, what is there ideally and what is there in actuality? So ideally, how the air should come from polar high pressure to the subpolar low pressure? Ideally, the air should come like this. Okay, this is the ideal scenario. Okay, ideally the air should come like this. Okay, why? Because this is high pressure, this is low pressure. So, but naturally the air should come like this, ideally. But which force will come into play? The Coriolis force. And mind you, the Coriolis force deflection is maximum. Okay, the Coriolis force deflection is maximum, and this Coriolis force deflection will result in what? This Coriolis force deflection will result in intense swirling of wind over there, and because of this, the wind, instead of coming in straight lines, it will start swirling. It will start swirling around the poles. It will start swirling around the poles. Okay, both 90° north and 90° south. So this I drawn as the ideal movement, but as soon as wind starts to come, it will start deflecting towards its right. So wind has to come like this, it is starting to deflect like this. So the wind is starting to deflect like this. The wind is starting to deflect like this. And because of this, if you go to the polar regions, you have what? You have a circumnavigating loop. This is called as what? This is called as polar vortex. This is called as what? This is called as polar vortex. So if I'm using the maps for your understanding, okay, so let us use maps too, so that you get a crystal eye view. What do you mean by this polar vortex? So if I open up the earth for you all, okay, so let me open up the earth for you all. So I'm opening the earth and I'm now discussing with you all what do you mean by polar vortex. Okay, so if I'm moving towards the poles like this, okay, this is our polar region. Okay, this is our north pole. Okay, this is our north pole. Okay, so this point over here, this is our north pole, okay, 90° north. So what you have around this region is a loop or a vortex like this. Okay, the wind is flowing in a circular path like this. Okay, this is called as what? This is called as polar vortex. And in what direction the polar vortex is flowing? From east towards west. Okay, so basically anything to the east of prime meridian we treat it as eastern hemisphere. So the direction will be like this. It will be coming from east towards west. Okay, so if this is called as what? This is called as polar vortex. Okay, and this polar vortex will do what? This polar vortex will keep the cold polar air confined to the polar areas. Okay, and if you have the breaking up of this polar vortex, if this polar vortex breaks, then the cold polar air will descend towards the tropical areas and you will have cold waves. So you must have heard in the Canada, you must have heard in USA, you must have heard in Europe that in some regions you have cold polar air coming. Why? Because the polar vortex will break. And why this polar vortex will break? You have two reasons. You have the meandering of Rossby waves and another reason is climate change. Climate change is causing the polar vortex to swirl even further northwards, even further southwards, and because of this swirling, the cold polar air is descending and you are having cold waves, extreme cold waves, like you had the cold wave in the Texas region of USA. Okay, Texas is basically a desert territory, but the temperatures over there reached minus 38 degrees Celsius. Why? Because of the descent of the polar area. So this I showcased you a bit to the polar areas. Now let me showcase the polar vortex to you with regards to the equatorial regions too. Okay, so I'm just shifting my focus of the diagram. I'm just shifting the perspective for your understanding. So let us now consider the polar vortex with respect to the equatorial area. So just assume this. So so this is our polar vortex. Okay, the polar vortex swirls like this. Okay, so this being our polar vortex, and mind you, what is the direction of polar vortex? The direction or the movement of air of the polar vortex is from east to west. So this is our east and this is our west. This is how the polar vortex circulates in the northern hemisphere, and this is how the polar vortex will also circulate in the southern hemisphere. And how will be the circulation in the southern hemisphere? So let us understand that too. Okay, so this is with regards to the northern hemisphere. Now let us understand with regards to the southern hemisphere too. So if now I am drawing the inverted loop for you all, okay, if we are considering the southern hemisphere, okay, so let us assume this to be our southern hemisphere now. Okay, so I'm not drawing the STHP for you all, I'm only using the SPLB for you all now. Okay, hello, yeah, so let's assume this is our SPLP. Okay, subpolar low pressure belt of the southern hemisphere. This is our subpolar low pressure belt of the southern hemisphere. This is 60 to 65 degrees south, and this is our polar high pressure belt. Okay, polar high pressure of 90 degrees south. Okay, so ideally how the wind should come? Okay, ideally the wind should come in a straight line from the polar regions to the subpolar regions. Okay, so the wind should come like this. So this should be the direction of wind. Okay, but what is happening at the poles? The Coriolis force is maximum, and because of this the Coriolis force deflection is also maximum. So instead of moving like this, as soon as the winds come, as soon as the wind starts to flow, it will start deflecting towards its left like this. It will start deflecting towards its left like this. So guys, what is happening at the polar regions, basically what are happening at the poles, anywhere you go, you will having a polar vortex which is moving from east towards west. And if I'm showcasing you with regards to the perspective of the earth per se, so let's do that from the earth perspective too. Okay. So if I'm now showcasing you the Antarctic region, okay, so this is our Antarctic region. Okay, so this is our Antarctic region for you all. Okay, and in this region the polar vortex will again circulate like this. Okay, this will be our deflection. Okay, this will be our polar vortex of the southern hemisphere. And if I'm showcasing you from the perspective of the equatorial areas, okay, so let's assume this to be our South America. Assume it's all of course there. So this is the direction of the polar vortex circulation. Okay, it will move from east towards the east to west. Okay, not drawing the exact, but for your sake of understanding, it will be over here, and in the north again you will have a polar vortex which is moving from east towards west. And mind you, if this polar vortex breaks, anyhow, the cold air will descend over the tropical and the temperate areas. The cold polar air will descend over here, and here you can have what, here and here you will have cold waves. What happened in the year 2019, 2020, the exact thing happened. Okay, sometimes it is referred to as blizzards. It is also referred to as Halloween storms in the North America. Okay, so Halloween, you all know, it happens during the Christmas, okay, during the December month, so you do have it as Halloween storms, but this cold air will descend towards this latitudes. Okay, so if I'm now painting the global winds for you completely, so let's open up that diagram again. Okay, okay, so these were our northeast and southeast trade winds. Okay, these were our westerly winds. So if I'm now showcasing you the polar vortex on a global scale, the direction will be like this. This will be our polar vortex. This will be our polar vortex, or it can also be called as what? It can also be called as the polar easterlies. So this and this, it will be called as what? The polar easterlies or the polar vortex or the polar vortex. So this will be again called as polar vortex. So please mind you guys, this is very important, this is highly technical. Okay, so I hope this concept is clear to you now. This will be called as what? Polar vortex or the polar easterlies. Okay, so now as we have painted this picture, so now let us paint this picture on the earth's outline, and let us try to understand the wind patterns with respect to the earth per se. Okay, so I'm opening up the 2D map of earth for you all now, and we'll try to assess what is actually happening globally per se. Okay, so let's open up the world's map on a 2D scale, and let's assume that what is happening over there. Okay, okay, so the equatorial low pressure belt is like this. This is our, let's assume this to be the equatorial low pressure belt. Let me use lines so that you understand it even more properly. So let's assume this to be our equatorial low pressure belt. Okay, let's assume this to be our subtropical high pressure belt. Again, this is our subtropical high pressure belt. Okay. This is our subpolar low pressure belt. Okay. This is our subpolar low pressure belt. Okay. And above what you have is the polar vortex. So polar vortex, I'm using very crude representation. So let's assume this to be our polar vortex like this. Okay, circular vortex, it's flowing from east to west. Okay, again the circular vortex, it's flowing from east to west. So this is our equatorial low pressure, this is our subtropical high pressure, this is our subpolar low pressure. Okay, this is our subtropical high pressure, this is our subpolar low pressure. Okay, so how are the winds coming? Okay, what is the direction of the winds that is coming? So the direction of the winds is like this. Okay, so between the subtropical high pressure belt and subpolar low pressure belt, the winds will come like this. Okay, the winds will be coming like this. Okay, these are our trade winds. Now if I am drawing the westerlies for you all, the westerlies will be like this. Okay, the westerlies will be like this. Okay, sorry, my bad. Okay, the westerlies will be like this. So what is happening basically? The rainfall that you have between the subtropical high pressure and the subpolar low pressure, all of the rainfall is incident on the eastern coast. All of the rainfall is incident on the eastern coast. Because of this, the east coast is dry, whereas the west coast you have deserts. This we discussed yesterday only. Now, please consider the temperate latitudes of 40° north and 60° south. So because of this westerlies, you will have incessant rainfall in this part of world and you will have incessant rainfall in this part of the world. Why? Because the easterlies will bring incessant rain from the Pacific. So this part of the world you will have a entry called as temperate. Rainforest. Please mind you guys, this is very very important. You will have an entry called as temperate rainforests. Okay, you must be wondering, sir, how come you are having rainforests in this part of the world? Why? Because the westerlies will be bringing more and more rain in this part. Okay, and if you have mountains, so mountains will act as orographic barriers, and you do have a mountain range over here called as the Rockies, and you have a mountain range over here called as the Andes. So you will have temperate rainforests in the western coasts of North America, the western coast of Chile and Argentina in the South America, and you will also have temperate rainforests on the western coast of New Zealand. So this is also where you will have the temperate rainforest. Okay, so New Zealand is not that clearly visible in this atlas, but we'll surely discuss this when we'll do the New Zealand. And now what will happen at the subpolar low pressure belt of the north? See, subpolar low pressure belt of the south is virtually in the oceans. Okay, so let's not discuss that. Let us assume whatever is happening on the land. Now, as you have the subpolar pressure belt on the north on the land per se, and as the air is rising, you are having low pressure, so you will have localized rainfall over there. Okay, and you have a mechanism in this latitude called as frontal mechanism. Why? Because Please understand this very, very properly. Okay. So I'm rubbing everything now. Okay. So if I'm zooming in only on this part of the world, okay. So if I'm zooming in only this part of the world, okay, in only this part of the world towards the Europe, okay. So here you have the subpolar low pressure belt like this, okay. So you are having the cold air which is coming from the north, you have the cold Arctic air, you have the cold Arctic air, and you have the warm air which is coming from the southern tropics. So you have the warm tropical air which is coming from the tropics. So this cold and warm air will now interact with one another, and this will result into a mechanism called as fronts and temperate cyclones. And because of this, you will have post upliftment along these latitudes, and anywhere if you go along 60 degrees to 65 degrees north, you will have rainfall almost throughout the year. Why? Because of the cold air coming from the Arctic meeting with the warm air coming from the tropics. Guys, a very crude understanding of the topic, but for now, for this level, this is sufficient for you all to understand that you will have what? That you will have the cold air which is coming from the north, and you have the warm air which is coming from the south. And so in this latitude, you will have incessant rainfall. And as you are having incessant rainfall throughout the year, mind you, the rainfall is not as high as in the tropical latitudes or as in the monsoonal areas, but the rainfall is fairly constant throughout the year. And hence, because of this, you will have what kind of vegetation in this world? You will have the taiga, coniferous forests. Coniferous forest means those forests are green throughout the year. And you will ask me, sir, how come they are green? Because you have rainfall over here well distributed throughout the year, because in this latitudes you have dynamism of the earth coming into play, where the cold air from the Arctic is meeting the warm air from the tropics. You have frontal mechanisms, and hence you have a vegetation over here which is called as the taiga coniferous vegetation, and hence you have big coniferous trees in this part of the world. Okay, so this is where I live today's session for all of you. Okay, I hope this session was good with regards to the understanding of conceptual clarity, and tomorrow onwards we'll pick up from this area only. We will pick up our discussion from the discussions of the taiga rainforest, and then on we'll move ahead with the discussions of the mid latitudes, the vegetation of the mid latitudes, and then from thereafter we will try to include a little bit of lithosphere of earth too, because I need to make you comfortable with the lithosphere of earth per se, with the plate tectonics. So little bit of those entries, and then in future classes we will start discussing the countries and the continents point by point wise, location by location wise. So guys, I hope that these classes are of great utilitarian value for each and every one of you, and these sessions are enlightening to each and every one of you. Guys, none of this will make any sense if you don't revise whatever I have been taught. And you have this utmost privilege, guys, that you have a medium like YouTube, you have institute like StudyIQ, which is giving you such quality content free of cost on YouTube. So guys, please utilize this content very properly. Guys, you will have n number of coaching classes, you will have n number of faculties which will teach you these concepts in one go. You will have 12-hour session, 13-hour sessions, but that does not make sense. Once you have the conceptual clarity of the topic, then any current affairs, any conceptual understanding of the entire discipline per se will be taken care of. Okay, so my name is Pritesh Maturkar. You can reach out to me on Telegram. The name of the channel is Geography by Pritesh Maturkar, and you can join it by just doing a global search, Geography by Pritesh, @Geography by Pritesh, wherein I keep on posting the relevant current affairs, and we will also post up detailed PDFs of some of the issues that I discuss, and using those PDFs you can get good marks. So please stay hungry for marks in mains. Whatever you see on this board, whatever you listen to me in these lectures, please utilize this for getting good marks in your mains. So I call this session off. Everyone, please work hard and smart, because that is what UPSC demands. See you all sharply at 5 PM tomorrow for session number 8, wherein we will continue our discussion from the taiga and tundra areas, and we'll move towards the discussion of the temperate latitudes too. Okay, thank you, Krishna. I hope that everyone is enjoying this session. So see you sharp at 5 p.m. okay, tomorrow. Have a nice day. Good night, everyone.